Welcome to Part 5, Operations and Optimization. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Congratulations on building a complete enterprise-grade Azure network. You have a working service chain with gateway transit, but building it is only half the battle. Today, we focus on operating, monitoring, troubleshooting, and optimizing this architecture for production use. I'll show you how to implement comprehensive monitoring that catches issues before users complain. We'll set up alerts for common failure scenarios and create dashboards that give you instant visibility into your service chain health. You'll learn troubleshooting techniques I've developed over years of managing these architectures. Performance optimization is crucial. Your NVAs can become bottlenecks if not properly tuned. I'll show you how to identify performance issues, scale your NVAs, and implement high availability to eliminate single points of failure. Finally, we'll look at automation. Manual deployment is fine for learning, but production environments need infrastructure as code. I'll provide ARM templates and Terraform configurations you can use to deploy this entire architecture in minutes. This final part transforms your architecture from a working prototype into a production-ready, enterprise-grade solution. Let's start with monitoring, the foundation of reliable operations. Implementing comprehensive monitoring. Effective monitoring is what separates a proof of concept from a production system. Let me show you how to implement monitoring that gives you complete visibility into your service chain. First, we enable Network Watcher in all regions where you have resources. Network Watcher is Azure's network monitoring service, providing tools like packet capture, connection monitoring, and flow logs. It's automatically enabled in most cases, but always verify. NSG flow logs are your primary source of truth for traffic patterns. They record every flow through your NSGs, including the source, destination, port, protocol, and whether traffic was allowed or denied. Enable them on all NSGs, especially those protecting your NVAs. Store logs in a storage account for long-term analysis. Traffic Analytics processes raw flow logs into actionable insights. It shows traffic patterns, top talkers, blocked traffic, and geographic distribution. The 10-minute processing interval is usually sufficient, but you can reduce it for more real-time visibility. For the VPN gateway, enable diagnostic logs for all categories. Gateway Diagnostic Log shows tunnel establishment issues. Tunnel Diagnostic Log reveals per tunnel statistics. IKE Diagnostic Log helps troubleshoot connection failures. P2S Diagnostic Log is for point-to-site connections, if you are using them. VM Insights on your NVAs provides crucial performance metrics. It shows CPU, memory, disk, and network metrics. More importantly, it reveals process-level details, such as which processes consume resources on your firewall or IDS. Connection Monitor continuously tests connectivity between endpoints. Set up monitors from each spoke to on-premises, between spokes, and to the internet. This proactive monitoring alerts you before users experience issues. A well-designed dashboard gives you instant visibility into your service chain health. Let me show you the key metrics to track and how to visualize them effectively. The traffic flow visualization uses a Sankey diagram to show traffic volume between components. This immediately reveals traffic patterns and potential bottlenecks. You can see which spokes generate the most traffic and where it's going. Gateway metrics are critical for hybrid connectivity. Tunnel count shows active connections, and drops indicate failures. Bandwidth utilization reveals if you're approaching gateway limits. The P2S connection count tracks remote users if applicable. Packet drops might indicate sizing issues. For NVA health, track both Azure metrics and internal metrics. CPU and memory usage show resource pressure. Network throughput reveals if you're hitting NIC limits. Active connections indicate load. Dropped packets suggest performance issues. Create separate panels for each NVA. This lets you quickly identify which appliance in your chain is struggling. Proactive alerting prevents minor issues from becoming major outages. Let me share the essential alerts that every service chain deployment needs. VPN tunnel disconnection is your most critical alert. When a tunnel drops, on-premises connectivity is lost. Set the threshold to 1 minute to avoid false positives from brief reconnections. Alert immediately. Don't wait for users to complain. NBA CPU alerts need careful tuning. Set a warning at 80% and a critical alert at 90%. High CPU might indicate a DDoS attack, a misconfiguration, or simply growth in traffic. The 5-minute average smooths out spikes while still catching sustained high usage. Packet drop rate is an early indicator of performance issues. Even a 1% drop can significantly impact application performance. This metric often increases before users notice problems, giving you time to respond. Gateway bandwidth alerts prevent surprise throttling. Azure gateways have throughput limits based on their SKU alert at 80% utilization to provide time for scaling decisions. Remember, bandwidth is bidirectional, so be sure to monitor both ingress and egress. NSG blocked traffic alerts help identify security issues or misconfigurations. A sudden spike might indicate an attack or a new application trying to communicate. Set baselines during normal operations, and then alert on any deviations. Let me share troubleshooting techniques for the most common issues in service chain architectures. These methods have saved me countless hours of debugging. Asymmetric routing is the most insidious problem. Traffic takes different paths in each direction, breaking stateful firewalls. Use Network Watcher's next hop to verify routes in both directions, from source to destination, and from destination to source. If paths differ, you have asymmetric routing. To fix asymmetric routing, ensure route tables are consistent. Check that both NBAs have routes for return traffic. Verify UDR priorities. More specific routes override general ones. Sometimes adding explicit return routes solves the issue. Performance bottlenecks usually appear at the NBAs first. Start with basic metrics: CPU, memory, and network. But don't stop there. Check process-level metrics to identify what's consuming resources. On Linux NBAs, use HTOP, IOTOP, and IFTOP for real-time analysis. For intermittent connectivity issues, packet captures are invaluable. Simultaneous captures on the source, NBAs, and the destination reveal where packets disappear. Time synchronization is crucial. Ensure all systems use NTP for accurate timestamps. The troubleshooting flowchart I am showing starts with symptoms and guides you to root causes. Save this. It's based on hundreds of support cases. Follow it systematically to avoid jumping to conclusions. 1. Performance optimization can dramatically improve your service chain throughput without additional costs. Let me share some techniques that have worked in production environments. NVIDIA sizing is your first optimization point. The table shows real-world throughput for different virtual machine sizes. Don't trust vendor specifications, as they're usually best-case scenarios. Plan for 60 to 70% of rated capacity to handle bursts. Accelerated networking is a game-changer, providing up to 30 gigabits per second of throughput with ultra-low latency. It bypasses the host OS for network traffic. Not all virtual machine sizes support it. DS3_V2 and above do. Always enable it for NVAs. Connection tracking tables can become full on busy firewalls. Each connection consumes memory. Default limits might be too low for production. On Linux, increase the contract table size and reduce timeout values for short-lived connections. TCP optimization makes a huge difference for WAN traffic. Enable TCP window scaling and selective acknowledgements. Adjust send and receive buffers based on the bandwidth delay product. For VPN traffic, these optimizations can double throughput. The SYSCTL parameters I'm showing are battle-tested in production. They increase buffer sizes, enable advanced TCP features, and optimize for high throughput scenarios. Single points of failure are unacceptable in production. Let me show you how to implement high availability for every component in your service chain. For NBAs, active standby is simpler but wastes resources. The standby NBA sits idle until needed. Use Azure Load Balancer health probes to detect failures and redirect traffic. Failover typically takes 10 to 15 seconds. An active configuration doubles your throughput capacity and eliminates idle resources. However, it requires connection state synchronization between NBAs. Many commercial NBAs support this natively. For Linux-based NBAs, consider Contract D for state sync. Zone redundancy protects against data center failures. Deploy NBAs across availability zones. One in Zone 1, another in Zone 2. The Azure Load Balancer standard SKU is zone redundant by default. This protects against zone failures without complex configuration. The VPN gateway in active mode provides redundancy and increased throughput. Both gateway instances actively terminate tunnels. Your on-premises device must support multiple tunnels. This eliminates the gateway as a single point of failure. Route table design for HA is crucial. Point routes to the load balancer front-end IP, not individual NBAs. This allows transparent failover. The load balancer handles directing traffic to healthy instances. Infrastructure as code. Manual deployment doesn't scale and invites configuration drift. Let me show you how to codify your entire architecture for consistent, repeatable deployments. The ARM template I'm providing deploys the complete hub and spoke architecture. Parameters allow for customization, including address spaces, NB sizes, and SKUs. The template uses loops to create multiple spokes efficiently. Copy conditions handle optional components like the VPN gateway. ARM templates are native to Azure and support all features immediately. However, they can become complex for large deployments. The JSON syntax is verbose, and debugging can be challenging. For a better authoring experience, use Visual Studio Code with Azure Resource Manager extensions. Terraform offers a cleaner syntax and better modularity. The configuration I'm showing uses modules for reusability. The hub module, for instance, encapsulates all hub components, and the spoke module can be instantiated multiple times. Variables make customization straightforward. Terraform's state management enables updates and modifications. It tracks what is deployed and only changes what is necessary. After years of implementing and supporting service chain architectures, I have learned valuable lessons. Let me share some best practices that will save you time and help prevent issues. Documentation is your lifeline during incidents. Document every design decision, IP allocation, routing logic, and security rule. Use diagrams liberally, as they are worth 1,000 words during troubleshooting. Keep your documentation in version control right alongside your code. IP address planning prevents future headaches. Reserve space for growth, because running out of IPs in production is painful. Use consistent schemes across all your environments, and be sure to document special IPs, like NBA addresses, prominently. If applicable, consider IPv6 right from the start. Good change management can save you from outages. Every change should be planned, documented, and reversible. Use maintenance windows, even for what seem like simple changes. Have rollback plans ready, and always test changes in a non-production environment first. Regular testing prevents surprise failures. Monthly failover tests, quarterly DR drills, and annual architecture reviews will keep your environment healthy. Automate testing wherever possible. Manual tests often get skipped when people are busy. Security reviews should be continuous, not annual. Regularly audit your NSG rules, review NVIDIA configurations, and validate your routing tables. We've completed an incredible journey together. Over 5 parts, you've built a production-ready Azure network architecture that provides enterprise-grade security, cost-efficient hybrid connectivity, and scalable operations.